All right, so we're back with 11.6. The question is number 13. We want to find the probability of selecting the 5 of clubs or the 8 of hearts. Okay, 5 of clubs or the 8 of hearts. Those are mutually exclusive. Okay, this is mutually exclusive events because there is no intersection or overlapping. That's it. So what's the probability of doing this? Well, according to our formula, we add the probabilities. We would say the probability of 5 of clubs plus the probability of 8 of diamonds. Okay. So the probability of the 5 of clubs is 1 over 52. And the probability of the 8 of diamonds, since there's only one of each, is also 1 over 52. And if you were thinking, well, we got 2 cards out of 52, why is it not just 2 over 52? And it is. That's another way you could look at it. 2 successes, or the number of successes is 2 over 52. And of course, that reduces to 126. Okay. So it's not too bad. I just kind of wanted to remind you what an example of mutually exclusive would be. All right, this one, number 14. We're going to do 14, 15, 16 on this video. Debated whether doing this one or not, but then I thought there is another question involving faculty, so I want to show you the difference of those. So the mathematics faculty at a college consists of 6 professors, 12 associate professors, 6 assistant professors, 12 instructors. If one faculty member is randomly selected, find the probability, and I always like to write down what I'm doing, of choosing a professor or instructor. So I don't think it's possible for someone to be both a professor and an instructor. So we don't have any overlap. So these are mutually exclusive. No overlap. Well, so that means that I will find the probability of a professor plus the probability of an instructor. Well, in order to find the probability of a professor, I need the total. What's the total number of faculty? Total number of faculty. Well, to do that, I add all these folks together. 12 assistant professors, 12 associate professors, 5 assistant professors, 12 instructors. Oh, and then let's see. I think I missed something. 6 professors, 12 associate professors, 5 assistant professors, and 12 instructors. Okay, so I just moved that over there. 24 plus 11, 41. Oh, wait, no, maybe not. I made up a number. Okay, 17 plus 18 is 35. So I was way off. All right, so 35 total faculty. That's what I need first. Now, the probability of a professor, well, there's 6 professors. Okay, so 6 over 35. The probability of an instructor is 12 over 35. So we have a total of 18 over 35. And this does reduce. They're both divisible by 3. Because if I add the numbers, oh, no, not divisible by 3. Nope. I don't know why I wanted to I guess I saw the 3 here, so I wanted to factor them both by 3, but no, that's it. This is 2 times 9, this is 3 by 7, so those are relatively prime. They don't reduce. So 18 over 35 is our answer. It's a little messy, so 18 over 35. Okay, and then number 15. Six-sided die, if they don't specify, they mean a fair six-sided die, is rolled. Find the probability of rolling an even number or a number less than 6. Well, here's what I need to do. I need to find all the possibilities of when I roll a die, what could happen. Okay? And from 11.4, if we roll a die, we get 6 possibilities. So I'm writing those down, and I am going to circle all of my successes. I suppose I could show you a way to use the formulas, but this is going to be easier. To find the probability of rolling an even number, 2, 4, 6, or a number less than 6. Oh, wow. Not including 6. Well, 6 was already even, so I've circled 5. I've circled 4. I circled 4 already. I circle 3 and I circle 1. And therefore, I've circled everything. So the probability of even or less than 6 is everything, 6 over 6. But you got to reduce that to 1. I think most of you will attack it this way. It's probably the most visually easy way to do it. But let's say you wanted to use the formula. So let's use the formula. Probability of even or less than 6. This is not mutually exclusive, not mutually exclusive, because there's some overlap. I'll show you with the formula, but I don't think you're really going to want to do it. This is the easiest way. All right, but let's say you wanted to do it with the formula. Therefore, since there is an overlap, okay, since there is overlap, not mutually exclusive. So again, this is easy. Do this. This is easy. Okay. But I could use the formula, the probability of even plus the probability of less than 6 minus even and less than 6. All right. So you probably already fast forwarded the video, but probability of even, okay, again, 2, 4, 6. That's 3 out of 6. Plus the probability of less than 6. 1, 2, 3, 4, 5. 5 over 6. Oops. Minus things that are both even and less than 6. 1, 2. So I get 3 plus 5 minus 2 over 6. 8 minus 2 is 6. over 6, which is 1. So that took me probably twice as long to work using the formula. And a lot of these that have overlap could be done if you kind of just count up all the things. We did an example like that in the homework or in the notes. All right, let's do number 16 and we will stop this video. I think I'm only gonna have one more video after this for 11.6. 16. Dealt 1 card from 52, find the probability. It is a 6 or black card. Okay. I think we kind of did one like this. But look, I could just pull everything out of my deck of cards. Now you can use a deck of cards on your homework or your quizzes. You can't use it on a test. But, you know, I could count up all of them. Maybe it makes it easier to see if I count up everything. So if we're talking about black cards, there are half the deck is black. There's 26 black cards. And then, unfortunately, 2 of those cards are, 2 of these 6s are black. So I could only count these once. Okay. So I think I'm going to use the formula. Although if you want to go through your deck of cards and you just want to pull out all the cards that are black or 6, you can do that. That's going to take a while. So I think using the formula will be quicker. So since there is some overlap, meaning that I have 6s that are both black and 6s, then this is not mutually exclusive, meaning there's overlap. There is overlap. Okay. So I'm going to use the formula. Probability of 6 plus the probability of a black card minus the probability of the black 6 and black, or black 6. And I'm doing it this way because, again, I just want more practice with this formula. All right, probability of a 6. There are 4 6s in a deck of 52. Okay. There are, half the deck is black, so there are 26 black cards. But how many cards are black and 6? So I have ended up counting these 2 black cards twice, so I have to take that away. So that's 4 plus 26 minus 2 all over 52. That's 30 minus 2, which is 38. And it doesn't reduce much. 38 is 17 times, or 19 times 2, so 19 over 26. Nope, that's not right. Let's see if I calculated this right. All right, so, oh yeah, look at that. Did you catch it? 4 plus 26 is 30. So let's fix that here. 4 plus 26 minus 2 is 28, not 38. Okay, those are both divisible by 4. So I could just type it in, but I could do this by hand. So 7/13. All right, so let's stop the video there. We are going to continue with the next page, probably just one more video.